Get out the handout that I gave you guys yesterday. In case I forget to tell you later, my plan right now is for us to have a Chapter 2 test at the earliest next Tuesday. And probably around Friday I'll have a better gauge of that, but right now I'm going to plan ahead. Next Tuesday. About time. Let's not do tomorrow.
It is.
Do Friday. Good. All right. Find two proofs that look like this. These are two very elementary style proofs, but they become arguments that we want to make inside a lot of other proofs. To kind of develop the routine of when I see congruency that I want to eventually maybe deal with equality, or vice versa. If I see equality, chances are maybe I want to think about congruency. When we look at this given information up here, our segment XY is congruent to segment BC. What we want to think about when we see that is if I had those two shapes in front of me, okay, and I had no way of measuring what they are, that at least tells me that they land on top of each other, right? Okay, I can put one on top of the other one, and they're going to match 100%. I don't know what their measurements are. I don't know how long they are, but they do have that feature that they're both the same length, right? So what we want to end up doing then is eventually converting that congruency idea and saying that shapes overlap back down to maybe a little more simpler of a way of thinking of it and saying that their distances are equal. Okay? Because now what this phrase here is saying is that whatever this number here is, it is the same as whatever that number there is. Still can't measure, still don't know what those numbers are, but it tells me that they're equal. Is that okay? It makes sense to do that because eventually we're going to want to start adding distances together. Or we maybe down here want to add angles together. Well, you can only add numbers, right? Okay, you can't add a shape to a shape and get a sum or a difference or something like that. You can only add or subtract or multiply or divide the numerical quantities that represent a distance or an angle measurement or something like that. Okay? So we need to be able to convert from a shape idea to a number idea. And that's what this proof is about. It's pretty easy, straightforward. Start with our given. Segment XY is congruent to segment BC. And that's given. And it's just a fact that we know that if two shapes are congruent, their distances have to be the same, right? Or two segments are congruent, their distances have to be the same. So we're going to make the jump straight to XY equals BC. Okay? Remember, this is shapes congruent, and this here says numbers, several number sign, numbers are equal. Okay? What allows us to do that is our definition of congruency. Definition of congruency, if I look in the back of the book, in the glossary, it will say, this is when two shapes are congruent, they have the same size, and they are the same shape. Okay? And that's what we're saying here. If we have two shapes that are congruent, we know they're the same shape, then we can say here that they have the same size. Is that doable? It becomes almost like a very routine process in a lot of our proofs. Okay? So it's those two steps are going to come quite a bit in other proofs. And what allows us to go from congruency to equality is the definition of congruency. It also allows us to go the other way. So if I started with these two things kind of flip-flopped, started with equality, and I wanted to make an argument that the two shapes were congruent, it's still definition of congruency, and I was going to do that. Okay. going to skip this one. This one's the same idea, but it's talking about angles now. Okay? Got two angles in front of me. I know I can overlap them. I can lay them on top of one another. And that tells me that whatever the degrees are for angle 1 and the degree for angle Z, whatever they are, I know them to be the same because the figures overlap one another, right? Okay. So that short proof gets used quite a bit in other proofs. And we'll see that either today or tomorrow and a couple others. Okay. This one here, did we do this one together in class yesterday? Okay. There's two classes I think we did this with and two classes we didn't do it with. So, when you see multiple things and you're given information, okay? See separate with a semicolon up there, sometimes separate with a comma or whatever. You want to write all that stuff down in your given. Okay. What I like to do is I like to just knock it out all at once in step number 1. Okay, and I like to stack them. I think it makes it a little bit easier for me to visualize what I'm going to try to do in a little bit if I stack these things. Okay. What you're going to see sometimes in questions that are already like kind of defined for you, they've already got some statements and already got some reasons. You might see them not put this right away, and they might, after 3 or 4 steps, put that in, and then write given as their 3rd or 4th step. Okay, which is fine, but if you think about how they do that, why they know to do that, is because they've already done the proof once. Okay, it's kind of a preliminary thing before they code it into Math Excel, and they realize, well, I didn't really need this piece of information until later in the proof, so I'm going to just move it to that point later in the proof. For us, we write anything by hand, any of these proofs that we do in class, we're going to write all our given information first, okay, and then throughout the questions, if necessary, we'll go through and talk about, okay, we list this given stuff first, but understand that this statement could have actually shifted down here and been okay if we put it there as a 3rd statement or 4th statement. Does that kind of make sense? So I'm going to show you kind of a routine that's going to help you get all these proofs done, but then talk about them and say how we can change them and still get the same argument, the same statements down.
Why is it a 4?
A 4, that's angle 1. Sorry. What we're saying here is if angle 1 is equal to 45 degrees and measure of angle 2 equals measure of angle 1, what we can end up doing here, okay, is using a very prevalent, very useful property that wherever I see angle 1, what can I replace it with? Okay, I can replace it with angle 2, and that would be fine. Okay? Everywhere I see angle 1, so maybe here measure of angle 1, okay, is equal to 45. So everywhere I see angle 1, I can replace it with angle 2, because in this statement, it says 1 is equal to 2, right? Is that what you're saying? Okay? So Cameron's talking about taking that information right there, and because 2 is the same thing as 1, up here, where I see 1, replace it with 2. That makes sense, everybody? What is it called when I replace something with its equal? Substitution. Okay? That's the substitution property we call it. Okay? Some people might have done this. Some people might have said it gains the same result. Okay? Some people might have said, well, I see right away that in this first line here, that angle 1 is 45, right? So then they say, well, anywhere else that I see angle 1, I can replace it with 45. Does that make sense? So instead of replacing 1 with angle 2 like Cameron did, we can come down here and say, well, everywhere I see 1, replace it with 45. And if I replace this 1 here with that 45, because it's still getting me measure of angle 2 equals 45. Yes. And it's still substitution. Okay? So in that particular problem, there's 2 routes you could have gone using substitution. Okay. Let's see if there's another route we could go. Okay, another route we could go. Let me see if I can pull these out. Not what I wanted to do. If you read this, measure of angle 1 equals 45, can you read that as 45 equals measure of angle 1? You read equations left to right or right to left. They're two-way streets, so you can do that. What if I did this? Because my given information, it's not specified that I have to show up in that order. So I could do something like this, maybe. First write that measure of angle 2 equals measure of angle 1, and then measure of angle 1 equals 45. Okay? And the reason I like to maybe see it that way is because now measure of angle 2 equals measure of angle 1, and then measure of angle 1 is equal to 45. Is this an idea of if that's A, and that's B, and that's B, and that's C? If A equals B, and B equals C, what can you tell me about A compared to C? A equals C, okay? That's the transitive property, right? Okay? So you could have used substitution as your argument here, or in this particular problem, you could have used the transitive property. Either one of them would have been fine. And that's a situation where one person might do the proof one way, somebody else might use a different property, a different technique or route, and you're both arriving at valid, true statements, so both proofs would be right. Okay. I like when I do a transitive property, I like to be able to do it this way to where I have kind of linear progression of one thing to the next, and then that next thing to a third thing. Because what I like to do is either stack them the way I've written them in here in blue, or maybe write them that way. And if I write them that way, those measure of angle 1s are the same thing, right? And now you can see 2 is the same as 1, but that's the same as 45, so you can get rid of actually the middleman and just be left with 2 equals 45. Okay? When I see the transitive property, or I think I want to use the transitive property, I start trying to visualize that movement of those terms and merging of them to come up with a new statement. All right? And I think that's a good idea for a lot of people to do, is start visualizing little intricacies like that that might help you with some of these proofs. Okay? That becomes, you're going to see this technique in other proofs today. So those two little steps that are going to be in a larger proof here towards the end. Now we have angle 1 congruent to angle 2, and angle 1 congruent to angle 3, and we're going to prove that angle 2 is congruent to angle 3. They don't give you a picture here, but I want to kind of draw a picture, and that might be something, a lot of times if they don't give you a picture, you might want to draw a picture to kind of convince yourself of what you're doing. And if you can logically think about, yeah, that makes sense, what I'm trying to do here makes sense, how can I then verbalize it? How can I write that down and share those thoughts with somebody else? And that's what our proofs really are. So we're saying angle 1 is congruent to angle 2. So I'm just going to draw 2 angles, angle 1, and we'll just clone that so we know exactly that those two things are 100% equal. Would you agree that those are congruent? Okay. So we're going to say that that's angle 2. Oh. So that's angle 2. And this given information is telling you, you know that. You know that those two things are congruent. Is that doable? Okay. The second part of information is saying you've got a third angle, angle 3, okay, you've got angle 3 over here, and that angle 3 is congruent to angle 1, right? Well, how many marks does angle 1 already have in it from the first congruency? That's 1 marking, right? Okay. When you have a shape that has a marking in it, and then you want to go back and put another mark in there, you can't do that. If you define it as having 1 mark, it's got to keep that 1 mark. Does that make sense? Okay. So I want to show that 1 and 3 are also congruent, but 1 has 1 mark in it. So how many marks does 3 have to have in it? If I can't change that one, doesn't that have to have 1 mark in it? Okay. And does that still tell me that 1 and 3 are congruent? Okay. And I didn't change angle 1, so I still have the idea that those two are still congruent, right? But now how many marks do all 3 of those angles have? They all have 1, right? So if they all have 1 mark, that means they are all related in the same way. So which 2 angles have we not talked about yet as congruent to one another? It's 2 and 3, right? Okay. So now we can say 2 and 3 are going to be congruent because of that process. Does that kind of make sense? Okay. So hopefully that picture, that image will help you recognize why we're doing what we're doing here. But the first thing we're going to do is say angle 1 is congruent to angle 2. That's your given. And angle 2, or not angle 2, but part 2, statement 2, angle 1 is congruent to angle 3. Okay? Still given. So I guess I don't need to label it as its own statement. Okay, so 1 congruent to 2 and 1 congruent to 3, that's all given. Okay. We should be able, if that's the information we have, we should be able to make the conclusion, make the jump, that angle 2 is congruent to angle 3 from what we said down here. Okay? With the logic of it, and I like to do this work on the side, is you should be able to take these 2 phrases and you should be able to reorder them any way you want to. Okay? Because they're independent phrases. One does not impact the other. And you should be able to read either one of them left to right or right to left. Does that make sense? If I say 1's congruent to 2, is it the same thing as saying 2 congruent to 1? Yeah, okay. And they're independent of one another because this congruency does not impact this congruency down here, and vice versa. Okay? So what I'm going to do is I'm going to rewrite that one. I'm going to say angle 2 is congruent to angle 1. That's rewriting. She's doing scratch work on the side. Angle 2 is congruent to angle 1. It says the exact same thing that does, doesn't it? And I'm going to leave this one alone. I'm going to say angle 1 is congruent to angle 3. Okay? Does that then give me the visual that I can put those 2 things on top of one another like that, and now I can go straight from 2 through 1 to get to 3, and it allows me to say 2 and 3 are the same. Okay? So I can automatically, once I piece these things together, reorganize these a little bit, reorganize them a little bit, I can come up with angle 2 is congruent to angle 3. Does anybody know that reason? Think about this. That's some object A, that's some object B, and angle 3 is some object C. A is equal to B, B is equal to C, Y is A equal to C. Transitive property. And we're talking about congruency, right? So we're going to call this transitive property of congruency. Just be careful with that when you get to homework or the intercourse exam or whatever. There'll be a drop-down window. And one of your options a lot of times is transitive property of equality. The other one's transitive property of congruence. And a lot of people just read the word transitive and they select the one that says transitive property of equality. And it says you're wrong. And that tells the state of Ohio that you're a bad geometry student. You're really not, right? You're just bad at reading. Okay? Or it's not even bad at reading, just bad at following through and finishing the problem. That shows up many times. That's a small 2-step proof that we're going to use over and over again in other proofs. Okay? And hopefully we can recognize maybe how simple that can be, and then how that's going to alleviate a lot of the issues that we have in other proofs. And I think it happens in this one here. Okay? A lot of times, and you're going to see this, especially when we get to chapters 3 and 4, we can kind of go through a plan, okay, a set of steps. And I showed you this step, the set of steps yesterday in the PowerPoint. These steps here, if you think about going through those steps, at no point in steps 1 through 6 do I tell you to look at what your proof statement is and to analyze that, okay? Because there's a lot of times maybe you don't know directly how to get from point A to point B the easiest way. So those set of 7 steps kind of get you to write all the information down that is necessary for you to get from A to B, but then you have to start piecing them together to get to what you're trying to prove. And this one, it might be a good idea to actually look at what you're trying to prove. Okay? We want to show that angle 3 is a right angle. Well, how do I know if an angle is a right angle or not? Say again? It's 90 degrees. Okay? You guys need to be more confident in your answer. Don't mumble. Okay? All right? Jenica? Okay? Don't mumble our answers. Confident? Know you're right. And if you're wrong, who cares, right? Okay. So, we want to show, in order to say that angle 3 is a right angle, I have to show that it's 90 degrees. Well, where do you know, or how do you know that it has to be 90 degrees? What type of statement tells you that a right angle has to be 90 degrees? See? Okay, the measurement's going to tell me it's 90 degrees, but what kind of statement? Is it a postulate? Is it a theorem? When I say that an angle is 90 degrees, am I classifying it as a type of angle? Not a proof. What kind of statements allow you to classify things? What kind of things allow us to classify a zebra based off of some rule, or classify a giraffe off of some rule? Not a theorem. We talked about this like second day of school. A postulate is something you have to assume is being true. It's a statement we have to take for granted. But how do I know how to classify things? How do I know you're a sophomore? It's a fact that we have created, right? There's characteristics that we have to meet for him to be a sophomore, right? And we set those characteristics up in a definition, don't we? Don't we define what a sophomore is? Have a definition what that means, and then once somebody meets those requirements, we classify them. So, when we say that an angle is a right angle, it has to have a measurement of 90 degrees. It having a measurement of 90 degrees is the definition of a right angle, correct? Okay. It's going to be very important that we understand when we're trying to classify something. That's what they're trying to do here. Can you classify this angle as some type of angle? You're going to be looking at your definition and thinking about what definitions I'm going to say that. Okay. So let's go through and try to do it. We got to start with this given information. Measure of angle 1 equals 90 degrees. Angle 1 is congruent to angle 2. And angle 2 is congruent to angle 3. That's all our given information. A lot of stuff initially. But hopefully we start piecing things together so we can start eventually talking about measure of angle 3. Okay? We know our goal is to get the measure of angle 3 to be 90 degrees, right? Right now, all we know about measure of angle 3 is that it's congruent to some other angle 2, right? That makes sense? That was in our given. So what I want you guys to kind of think about, though we've got 3 things up here, it might only be useful initially to talk about those 2 things. Okay? And measure of angle 1 equals 90 might not be something that we need right away. Okay? And it comes from practice and recognizing and realizing that, how do I know to choose those 2, to look at those 2? Because I know I want to start talking about angle 3. So I'm going to try to choose things that deal with angle 3 as soon as I can. Okay? So let's talk about angle 3. What new argument can you make? If those 2 things are true, what new argument can you make that you are not provided with initially? Okay? Good. Angle 1 is congruent to angle 3. Okay? If 1 is the same as 2, but 2 is the same as 3, we can make the link that those 2 things are the same. And what is that property? Transitive property. And we're using congruency against the transitive property congruency. Okay? So inside this proof, there's going to be more steps. But you see inside that proof, we've got this proof we did earlier, right? Okay? It's the exact same steps. But now we're going to build off that even further. Now, we have angle 1 being congruent to angle 3. Well, here's what's nice, is that once we have angle 1 and angle 3, we now have angle 3 referencing back to being the same as angle 1, don't we? If 1 is congruent to 3, that means if I had those two angles in front of me, they would overlap, right? They would, we would cut and paste one on top of the other. Well, if one of those has a measurement of 90, what's the other one have a measurement of? 90 as well, okay? But what we have to do is kind of a tactical or technical thing here that we have to pay attention to. This is just telling me the shapes are congruent. This tells me nothing about their measurements, okay? It says the shapes are congruent. It tells me I can go ahead and say that measurement of angle 1 equals measurement of angle 3. Okay, and we'll see here in a moment why we have to do this. But if you remember back to the first proof we did, it's this concept here. If I have two shapes that are congruent, a lot of times we want to talk about their distances. Okay? Or in this case, if we would have done this one, we'd have two angles that are congruent, and then we want to talk about their measurements. And that's what we've got going on right here, is that we've got two angles congruent. Let's talk about their measurements. The reason we want to do that is because now, looking at those two things, there's a direct substitution that we can make with measure of angle 1. Okay? But what allows, before we get to that next step, and I do this occasionally, I get ahead of myself and I forget to write my reasons down. If I went from congruency to equality, which is exactly what we did here, right? We went from congruency to equality. What's my reason? Definition of congruency. Okay, so definition of congruency. Okay. In Math Excel, we'll say like definition of congruent angles, because definition of congruency is just something, a phrase that is comprehensive of all shapes. So two triangles congruent to two triangles, two quadrilaterals congruent to two quadrilaterals, two segments congruent to two segments, two angles congruent to two angles. That's all inside definition of congruency. Math Excel is more specific, and they'll talk about what angle or what shapes you're talking about. Definition of congruent angles, maybe say definition of segment, congruent segments. So just be on the lookout for that. But now, like I said, we look here that phrase 1 is equal to 3, and this up here that measure of angle 1 is 90. Now, anywhere I see measure of angle 1 throughout here, I can replace measure of angle 1 with 90, right? So now I get step 4, replace that with 90, and now I've learned that with that given information, piecing some new things together using our law of detachment and law of syllogism, okay, because that's really what we are doing here to create steps 2 and 3. We now get to step 4, that measure of angle 3 is 90. So now I have an angle that has a measurement of 90 degrees. And this was, if I go from this statement here and I replace measure of angle 1 with 90, what was that reason? Substitution. Okay. But now, it's not enough to say that it's 90, because remember, we're reading or writing these things to people that have absolutely no idea about geometry, right? Have very limited foundation geometry. So we need to tell them, hey, when you have an angle that's equal to 90 degrees, that is what type of angle? Right angle. A right angle. So now we can classify this as a right angle. Angle 3 is a right angle. And how did you know that angle 3 is a right angle? So I can hear you guys.
Definition.
Huh? Definition. Okay. I get a lot of people saying this is 100% right. I get a lot of people say, well, I know it's the right angle because we've shown that its measurement was 90 degrees, right? Okay. And that's what they want to write over there as the reasons, and that's fine. Because if you say, because it's shown that the measurement is 90 degrees, what you've actually written down there in your reason column is the actual definition phrase that you would see in the back of the book, in the glossary, of a right angle. Does that make sense? Okay. But understand that the way we write things here, some of our definitions might be paragraphs long. But we want to write that whole paragraph over here. Okay. So we don't necessarily write the paragraph. We say, we know because we already know what the definition of right angles are. We know what the phrase says. We're just referencing that phrase. Okay, so I have to write because it's 90 degrees and that's the definition of right angle. Whenever, and this is just something it's not the best thing to do, okay, but it does work occasionally. I would say probably 90% of the time. If I introduce something, if I classify and identify something as being, in this case, a right angle, my reason for classifying it that way is the definition. That's what definitions do for us, is classify things. Okay? So if I get stuck, I'm not sure what the reason was. If I introduce a vocabulary word, okay, and classify something that way, then my reason is going to be the definition of that vocabulary word. Okay? So if I said, M is a midpoint, my reason would probably be definition of a midpoint. Okay? I don't want you guys to learn how to do things that way. I don't want you to learn kind of a procedure or a process that circumvents an understanding of what we're really doing here. Okay? Because there you can, and I've had this done in the past, you can learn this stuff, you can learn these steps and do these steps, and you can be pretty successful at proofs. But you're just being robotic and you're doing routines and patterns and you're not really recognizing what we're really doing. Does that kind of make sense? People in Math Excel, I think you guys have probably done this in maybe algebra. If you didn't understand what was going on in Math Excel, you could do that question wrong a couple times and you can start to see maybe a pattern in the answers, right? And then for your problem, you can recognize that pattern and you can answer that question right. But doesn't that harm you in regards to that style of problems? You're not really going to learn how to do that style of problem, right? Okay. So that's the idea. I give you these steps to kind of help you get unstuck at certain times, but it's not meant to be kind of an end-all. This is all I've got to do because you're going to glaze over and you're going to miss some key components to things if we try to circumvent the understanding of these proofs. I think this is like slide 12 or something like that. Should say yes. Slide 12 of yesterday's PowerPoint. Like I said yesterday, I suggest printing this off, but I want to talk about it before we get to the next example. The first thing you want to do in all these proofs, this will get you about 80% of the proof done, if not more. Okay. You want to write down your given information in statement number 1, right? Given as your reason number 1. And that's just consistent on all these proofs. That's the easiest thing to do. Okay. Step 2 says if there is anything in your given that talks about congruency, maybe congruent angles or congruent segments or congruent triangles or whatever, we want to reference our picture and we want to draw that information into our picture. So what's going to happen is we're going to go through 8, 9 steps in some of these things. And it's going to be really hard for us to make connections through all the verbiage that we have written in our statements. It'll be a lot easier to look at our picture and make connections from our picture. But you can only do that if you start amending and fixing and correcting your picture as you go through the proof. Okay? So once you learn something about congruency at any point in a proof, you go to your picture and highlight that. Okay? Fill it into the picture. The next thing you do is you look at vocabulary words in the given. There's a key vocabulary word in the given. It probably tells you something. Okay, so if I see midpoint, it tells me I'm going to have 2 segments that are congruent. If I see angle bisectors, it tells me I have 2 angles that are congruent. Okay, so they're hiding some information inside vocabulary words. So we look at those vocabulary words and we write down in our statements what those vocabulary words provide us for our problem. Okay, so if it says midpoint, then it should give me 2 congruent segments. So for our problem, I go find them what are the names of those 2 congruent segments in our problem. Okay, and I write that down. And once I write that down, I go to my picture and I draw that in on my picture. Okay, and I do that for every single vocab word that is listed inside my given. All right, that gets you step 5, and step 5 is something that early on should be kind of easier to do, but the further we get into the class, the more things we learn and the harder this becomes. But you want to look at your picture and think about what are the shapes in that picture. Is it strictly segments? Because if it's strictly segments, then I don't have to worry about any angle ideas. Does that make sense? And it kind of narrows my focus on all the geometry that we've learned just down to the information that regards segments. Or if it just has angles in it, Okay, now I can just focus my attention on just the geometry that deals with an angle. Eventually in chapter 4, it's going to be triangles, and I can focus just on triangle information. Or chapter 3 is going to be parallel lines, so I focus on just parallel line stuff. So it becomes very useful to be able to look at my picture and think about what it's talking about, what it's wanting me to use, because it'll basically eliminate maybe 9 chapters of information and focus myself on maybe half a chapter. Does that make sense? So that's going to be useful, step 5. Step 6 and 7 are the hard parts. 6 and 7, once you've written all your statements down that you can gain from vocabulary from your picture, you've got an idea of what kind of section or chapter you're dealing with in regards to maybe addition, postulates, or triangles or whatever. 6 and 7 are going to be piecing together your statements that you've made and come up with a new statement from them. Okay? So using the law of the attachment, the law of syllogism, that kind of stuff, to create something new that is truthful. Okay? And hopefully, that new piece of true information that you develop matches what you wanted to prove. If it does, you're done. Okay? If it doesn't match what you want to prove, but it is true, you take that piece of information with all the other statements and you start trying to piece new stuff together and come up with a new statement. And you keep doing that until your new statement matches what you wanted to prove, and you're done. Okay? So these 7 steps, 1 through 5, should be pretty systematic, pretty easy. Everybody should follow those. Okay? 6 and 7 take some thought, take some understanding based on the content that we're dealing with. This is also problematic for some people because we don't take the initiative to learn our vocabulary. Okay? So make sure you know your vocabulary, and that's going to help you be a lot more successful in these things. I always ask that people always come back, how can I do better proofs? How can I get better proofs? And so I just start asking what definitions are. I'm asking what's a midpoint? What's an angle bisector? What are skew lines? What are parallel lines? And they can't answer 2/3 of those things. And that's what I tell them. You need to learn your vocabulary, and it's going to make things so much easier for you. So let's do this one. I'm not sure if this is the direct next one on your paper. Now, so sift through that paper and try to find this one. We'll get this one done and we'll go to lunch. Alright, so that stuff there is all our given information. This is what I wanted to talk about with those 7 steps for, is inside that given information, there's a lot of stuff. Okay? They pretty much be giving me everything I need to be able to show this proof statement is true. The goal is to show that line segment right there, AE, and that line segment there, BE, to show that they're congruent. Okay? So that's the overall task. And the given information is going to be enough to really get me there, but we have to pull apart and actually write down exactly what the given information is telling us. Okay? So the first thing I said, write your given down, and then if there is anything about congruency in that given, go to your picture and fill that in. So would you guys agree that this is a congruency statement that was provided in our given? I'm going to go find those 2 things in my picture, ED and EC, and I'm going to put a mark on them. Okay? And the reason I do that is because later on when we get 5, 6, 7 steps in these proofs, it's going to be a whole lot easier to look at that picture and know that ED is congruent to EC than have to sift through all my statements and find that. Okay? So always, when you learn a congruency, go back to your picture and fill it in. All right. Step 2 was if there is a vocabulary word. If there's a vocabulary word inside your given statement, you want to write down what that vocabulary means for your particular problem. Okay? So when I see midpoint here, that tells me something for this problem, right? Midpoints in general always give you what? The middle, and it takes your original segment and does what to it? Cuts it in half, and those 2 halves that you get are what to one another? Congruent, the same. Okay? So when I see midpoint, right away, we always want to associate midpoint with two congruent segments. That's what you get from a midpoint. So, for this problem, it's going to be different for every problem. Midpoint, same idea. I'm always going to get two congruent segments, but in this case, for my problem, it's the segments of AC. So I go look at AC. I'm just going to highlight it here for us. Leave that segment there. Okay? What are the two segments that I get if E is the midpoint? AE and EC, right? Okay? So I'm going to write that AE is congruent to EC. That's what you get when E is the midpoint of AC. You get two congruent segments. You can name those. Now, obviously, in another problem, if A is not called A, maybe it's X, and C is called R, you're going to have different labels, right? You should still have two congruent segments. Now, when I create a congruency statement, I want to go to my picture and I want to draw that in. Okay? So I want to show everybody that AE and EC are the same length. Okay? And what happens in this situation is that we've already got a marking in one of those segments, right? We've already got a marking in EC. So I don't want to change that marking, because if I change that marking, I now say that EC and ED are different, right? So because that already had one marking in it, I leave that alone. I come to AE, and it has to have one mark in it as well now. Does that make sense? Okay. So now looking at my picture, now I know there's three things that are congruent up there, right? And we could take from those any two that we wanted to and say that any two of those segments are congruent. Okay. But we also said that was the midpoint of BD, right? So let's look at BD. BD is that segment. So what two segments there should be congruent from BD? DE and BE. Okay? And if you want to call them ED or DE, BE or EB, it doesn't matter, right? The way we name our segments can be reversed. All right? Now, these congruency statements came from midpoint, right? That's how we develop them. And we know, if we're looking at the glossary of the book, it's going to say a midpoint is the point of a segment that provides you or cuts a segment into two congruent segments, right? So these were developed, these are true because of the definition of a midpoint. And that follows exactly what that slide said, those 7 steps. When you write information about your picture because of a vocabulary word, your reason, 90% of the time, will be the definition of that vocabulary word. Okay? There's be a couple times where that doesn't happen, and then we'll talk about those special situations. Okay? Now, here's the idea, because we're almost done. I want to go back to my picture, DE and BE. DE has one mark in it, so I got to put one mark in BE. Now, if I look at that picture, I have 4 segments that all have one mark in them, right? So I have a group of things that are all the same. Let's say I have a group of students that I have 100 students and they're all the same. Can I just pick out 2 of them and say that they're the same? Does that make sense? If I have an object or a collection of items and they're all the same, you should be able to take out any 2 of them and say any 2 of them are the same. So, of these 4 things up here, these 4 segments, are 2 of them AE and BE? Yeah. So I'll pick those 2 out and say AE is congruent to BE. And my reason then is the transitive property of congruence. When you have a cluster or a grouping of things that are congruent, you can pick out any 2 of them that you want to and say that any 2 are congruent. And the logic is if the A, then B, and B equals C, and then A equals C, logic or progression says if I start with AE is congruent to EC, so that statement right there, and then I pull out this segment here and say EC is congruent to ED, okay, and then come to this segment here, or this congruency here, I can write ED is congruent to BE, and you see the progression that if I start with this thing, It's the same as EC, but EC is the same thing as ED, but ED is the same thing as BE. So I can link those two things together, and it's actually translated property twice, but it doesn't really matter how many times we use it in a row. That make sense? Okay. No homework tonight other than finish that math Excel stuff, and it's really not due till Friday. My hope is that maybe you have some questions about that stuff. Answer those before it's due. Have a great rest of the day.